Morning, everyone, and welcome to the Mathematical Literacy webinar for grade 10s this morning. I'm going to give a few more minutes opportunity for the rest of the attendees to join us to join the webinar this morning. So be patient, just wait a few more minutes. We will begin shortly. Okay, it does look like the majority of you are signed in and ready to go. So let us start. My name is Kimberly Brits. I am the Educational Specialist for Mathematical Literacy. Now, before we begin this webinar, let's just cover some of the basics. If you are struggling to hear me, make sure your audio is on and your speaker volume is turned up. You will automatically be muted when joining this session. Should you have any questions, you can ask your question in the question box below or on your right, or you can simply raise your hand. To raise your hand, click the icon on your dashboard below or on your right. Download this presentation and additional resources in the handout box below or on your right. You will also find all this information in the question box below or on your right. Remember to send us your questions. Attendees are encouraged to ask questions and leave comments. However, irrelevant or inappropriate comments will result in the attendee being dismissed from the session. If we did not get to your question, please send us an email to academics@impact.co.za. Questions in the question box will be answered and made available afterwards. If you did not receive the questions and answers, please send an email to info@impact.co.za. Visit the Impact YouTube channel for recordings of this session. So I would just like to take the opportunity at this time to just cover some other basic things that I see many of you inquire about. So first of all, after this session is finished, I will get back to all of your questions, the ones submitted in the question box. So please remember to keep an eye on your emails, as I will be giving feedback via email. If you have any content related inquiries after this session, so if you start working through the activities, if you go through the slides again and you see that you want to inquire about something, you are more than welcome to send an email to academics@impact.co.za. Any other general inquiries, for example, impact registrations, June examination, and so forth, those inquiries you can send to info@impact.co.za. So we are aware that sometimes the internet does glitch, and for a few seconds you are unable to see me, you are unable to hear me. So in the case that that might happen, please remember that our videos and webinars, they are all made available on YouTube on the Impact channel. So please go and look at the webinar session again if you feel that you might have missed anything that we said during today's discussion. Then lastly, the notes from previous weeks as well as our previous webinar slideshow, all of that is available on guided learning. And then today's slideshow as well as additional activity and task handouts, they are all made available in the handout section on the right of your screen. So please do remember to go and download the handouts before the session ends. Okay, just an overview of our term 2 topics. These topics, we have looked at them a few times in the past week, so I trust that they are not new to you. We have already covered finance in the first 2 weeks, and the notes last week was on maps, plans, and other representations. So we are done with those topics. Today we are going to be looking at measurement, which includes distance, length, mass, volume, and temperature. Now, just some background before we start with the real work. In the world, there are two measuring systems used. One is called the metric system and the other the imperial system. So the difference between the two is that the metric system is a decimal-based system of measuring referred to as the International System of Units, or for short SI. So the reason for it being called the International System of Units is that the metric system is the system used widely across the world. So the majority of countries use this system. Now, this system includes measurements with meter, kilogram, liter, degrees Celsius, and many more. When we look at our imperial system, we deal with measurements done in yards, gallons, pints, Fahrenheit, feet, and so forth. So you should have heard of these measurements. Now, just for interest's sake, this is not something that you are required to know, but as we always know, we learn about new things, but we don't always understand fully where they fit in. So here you will see that the imperial system, that is the system that includes gallons, pints, feet, and so forth. The countries shaded in gray on the world map, those are the countries, the USA, Burma, and Liberia, the countries that use the imperial system. The remaining countries here displayed in white is the countries that make use of the metric system. Now you will see here in South Africa, as here at the bottom, we make use of the metric system. Therefore, we measure in millimeters and kilogram and liters and so forth. Now, with that said, let us start with the official work for today's topic. Now, measuring length and distance. First, I want to distinguish the difference between length and distance, because strictly speaking, those two things are actually one and the same. Now, when we talk about length, we talk about measurement of a short to medium length object. In other words, a short measurement. So we talk about the length of an arm, the length of a table, the length of the door, the length of the swimming pool. So we always refer to a short to medium length object, and we talk about length. As soon as we talk about distance, we talk about distance when we refer to the physical distance between two places or objects. Now, in other words, in short, that refers to long measurements. When we talk about the distance between two countries, we talk about distance, not length. When we talk about the distance around the track field, the distance around the school, we always speak about distance and not length. So it's quite simple. There is not really a big difference between the two. Now, the following conversions are extremely important, and I hope that some of you are familiar with some of these conversions. If you are not familiar with them, if you are not at a point where you know some of them off by heart, I encourage you to go learn them. It is extremely important that you know the following conversions off by heart before you enter a test or an exam. So without further ado, 1 centimeter equals 10 millimeters. 1 meter equals 100 centimeters. 1 kilometer equals 1,000 meters. Now, I have come across learners where they write out centimeter, meter, kilometer. That is not necessary. You are more than welcome to just use the abbreviation as it's shown here in brackets. So those three conversions has to do with length and distance. And as I said, they are not given in an exam or test paper. So it is really important that you study these three conversions before you write an exam or test. Right, now let's go here to the physical practice and application of those conversions. So you will see that there's a diagram here at the top of the slide. Now, this is an extremely nice diagram, and it is an easy diagram to learn. So you will see that we start here on the left with kilometer, which is our biggest measuring unit, talking about length and distance. Then we go to meter, slightly bit smaller measurement unit. Then to centimeter, which is even smaller. And then millimeters, our smallest measurement unit for length and distance. Now, the purpose of this diagram, I hope some of you have seen a diagram similar to this one. If you haven't, pay close attention because it is extremely important that you understand this diagram. So this diagram is used to convert between measurements. You will see here the examples to move from centimeters to kilometers, from meters to centimeters. So very important that you note, if we move from a big measurement unit to a smaller measurement unit, we will follow the top arrows, which imply that we multiply between the units. If we jump from our smallest measurement unit and we go to bigger measurement units, we will work with the bottom set of arrows, which indicates that we need to divide. Okay, now the purpose of this big jump, I will get to that a little bit later, but at the moment, don't worry too much about it. So without anything further said, let's go on to the first example. Now, I tried to put out my steps or my calculations in 3 steps just to make it a little bit easier for you to understand. So first of all, when we are going to do a conversion, the first thing that we need to determine is whether we will be dividing or multiplying. Now, it's simply easy to do. We have a number here or a value here in centimeters, and we have to convert it to a value in kilometers. Okay, so if we look at the set of arrows given, we are going to make use of the bottom arrows, which tell us that we will be dividing. Now, that is step 1 done. We determined we will be dividing. The second step will be to determine how many zeros you need to jump. So extremely important at this stage that you pay attention to what I'm saying. So over here, we are going to be following 2 sets of arrows. Now, the first set of arrows says that we need to divide by 100. The second arrow, divide by 1,000. Now, the number of jumps is determined by the number of zeros in these 2 values. So you will see 100 has 2 zeros, 1,000 has 3, and therefore 2 plus 3 gives us 5 zeros, and that equals to 5 jumps. Now, if you're not sure what I mean by jumps, we'll get to that in the next minute, so just bear with me. Step 3 is make the jumps starting at the comma or alternatively at the end of the value. Now, let me show you those 3 steps in a practical application. So over here, we have our value, 412 centimeters, our measurement. Now, we determined from centimeter to kilometer, we will divide, and we are also going to make our jumps in the direction of these arrows. So we are going to be making 5 jumps, as we determined, to the left. And now our third step said we will be making those jumps starting at the comma or at the end of the value. Now, important, 412 does not have a decimal at the end. Therefore, we are simply going to start at the end of the value. And we are going to make 5 jumps to the left. Now, there where our jumps end, we will put a comma in, and therefore, our answer is 0,00412 kilometers. Now, just pay attention here that I trust none of you have ever seen a value start with comma, there's always a number in front of the comma. So it's extremely important that you place a 0 in front of the comma. The 0 simply acts as a placeholder, someone to keep the chair warm. So it is important that you put that 0 there. And then the empty jumps, as indicated here, you also fill with placeholders, which is zeros. So it's quite simple, not really that difficult. And if you learn this diagram, if you study it, if you know it off by heart so that you can copy it onto a piece of paper without having to look at this one on the screen, you are halfway there. Let's look at the second example. So we are now moving from meters, or converting rather, from meters to centimeters, which means we will make use of this one arrow over here at the top, which says multiply by 100. Now, at this stage, I would like to inform you that you do not need to make use of this jump method that I explained here. You can simply type it into your calculator. So you can say 1,756 multiplied by 100, and that is a quick, easy, and almost mistake-proof method of getting to these conversions. So that is one way that you can do it, but I feel it is important that you understand how to work this jumping method as well. So if we look meters to centimeters, we are moving to the right by 2 zeros, therefore 2 jumps. There's no comma in this value, so we start right at the end, 2 jumps. That gives us a final answer of 157,600. Now, for the last example, I would like to give you the opportunity to also practice reading this diagram. So I'm going to give you a minute to do that last conversion for me. You can use your calculator, you can use this jumping method that I've explained, and then you can submit your answer in the question box. So I would like to see that you are all participating in us practicing together. So I'm going to give you a minute to quickly show me your answers. Thank you. There's 2 of you that submitted your answers thus far. So where's the rest of you? Are you still in bed sleeping this morning? There we go. Now I see some answers coming through. That looks great. I see there's some 2 or 3 of you that's not entirely on the right track, but we'll cover that just now. So I'm going to show you all what the correct answer is. Okay. Okay, let's see. It looks really good. It looks like the majority of you are understanding this really well. Now remember, this is the basics of measurement. So for grade 11 and for grade 12, they are going to expect you to know this off by heart already. So it's extremely important that you get this and that you understand this well right now. Okay. All right. I think let's look at the answer. So we had to convert from centimeters to millimeters. So look at the diagram, centimeters to millimeters, which means make use of the one top arrow which says multiply by 10. Now, for those of you who used your calculator, you would have said 31,8 times 10, which would have given you an answer of 318. So all of you who got the answer of 318, you can give yourself a pat on the shoulder. Well done. It means that you understand how to use this diagram, which is great. For those of you who did not get this answer, quickly pay attention. So 31,8 centimeters to millimeters, if using the jumping method, we are going to make one jump to the right, because there's 1 0, so therefore one jump, and the arrow indicates that it's going to be to the right. And now this value already has a comma in, So we are not going to start at the end of this value. We are going to start there where the comma is. And we are going to simply make, one jump to the right. So that comma now moves to the end of the value, leaving it at 318. So I hope all of you understand it up to this point. We are now going to move on to the next thing that we measure, which is mass, or rather weight, which is a more general term that we talk of. So when we measure weight or mass, it is the amount of matter in an object that we are weighing. Now, since we are measuring, there's another set of conversions that you are required to know. So first of all, 1 gram equals 1,000 milligrams. 1 kilogram equals 1,000 grams, and 1 ton equals 1,000 kilogram. Now you will find that I go through these conversions quite quickly because there's not much explaining to do around them. You will find that milligram is your smallest measuring unit. Therefore, there's a lot of small measuring units in one bigger measuring unit. Same for ton. Ton is our biggest measuring unit. Therefore, in 1 ton, there is going to be 1,000 smaller kilograms, if that makes sense. So these three conversions is not given in an exam or test. So once again, go study them, try to learn them off by heart, because you will not receive them in a test or in an exam. All right, now we are moving on to our second diagram. Now you will see that this diagram looks extremely similar to the one that we used for distance and length, but pay attention to the values over here. They are not the same. So it's extremely important that you know that the diagrams are different from each other, because the values that you multiply and divide with, they're different depending on what you are measuring or converting. Now, let's go on to the first example. We are converting from gram to milligram, which means we are making use of the top arrow here, which says that we need to multiply by 1,000. Now, once again, type it into your calculator or use the jumping method. I hope that you will, with both ways, get to the same answer. So first of all, 560 does not have a comma in, so we are going to start our 3 jumps, because there's 3 zeros, right at the back, and we will be making those 3 jumps to the right, because that is what our arrow indicates. Now the comma now moves to right at the back, and therefore our answer is 560,000 milligrams. It is as simple as that. So the idea or the concept behind how to use these diagrams, it's the same, doesn't matter what you measure. Let's look at the next example. 4,200 kilograms converted to tons. So here we have kilograms. We want to convert it to a measurement in tons. So we will be making use of the bottom arrow, which says that we need to divide by 1,000. So 4,200 divided by 1,000. If you have a quick brain when it comes to mental maths, you will find that the answer is going to be 4,2. If you are going to be making use of the jumping method, remember 3 zeros, therefore 3 jumps to the left, starting at the back of your value, because there is no comma in 4,200. So let's say 1, 2, 3 jumps to the left. So our comma moved in right here between the 4 and the 2. It gives you an answer of 4,2. Now you will note that I did not include these 2 zeros in my answer, as they do not really contribute to the answer. These 2 zeros are simply placeholders. So you can leave them out of your question, or you can leave them in, saying that your answer is 4,200. Regardless if they are there or not, the answer remains the same and you will get your marks. Now, once again, I would like to give you the opportunity to practice your skills. So this last example here at the bottom, we are converting from kilograms to grams. So kilograms to grams. I'm going to give you another minute to give me the answer for that conversion. Once again, Please give me your answer here in the question box. Oh, I see many of you already answered it. Great. Okay, the majority of you looks like you are getting it now. One or two of you I see. Someone left a question mark behind their answer. Am I supposed to tell you if it's right or wrong? Okay, let's see. It looks really good. I'm happy that the most of you understand it so well. Okay, I'm not going to spend too much time on these examples. So let's go straight into the answer. Now, first of all, kilogram going to gram, we needed to multiply by 1,000. If we did not use our calculator but the jumping method, we would have made 3 jumps to the right, starting at the comma, because this value does have a comma in. So 1, 2, 3 jumps, and now the comma is just behind that 1. Now the 3 zeros in front of 1 does not contribute towards the value. So therefore, if you simply said that the answer is 1, you are on the right track. Once again, give yourself a pat on the back because you are understanding it really well. Okay, let's move on to the next subject or topic rather. We are now looking at volume and capacity. Now, when we talk about volume and capacity, that is the 3-dimensional space occupied within an object. So a jug, a box, a bottle, anything that is a 3-dimensional object in which you can fit something else. That object has a volume and a capacity. Now, there's 2 types of volumes that we can look at. The first one is a liquid volume, which we measure in kiloliters, liters, and milliliters. Then we can also look at a solid substance. So that, for instance, is if you put a bunch of Lego blocks into a big box. So the object with which you are filling the 3-dimensional big object, they are all solid. This we measure using cubic meters, cubic centimeters, and cubic millimeters. Now, once again, here are a few conversions that you unfortunately do need to study and know off by heart. So 1,000 cubic centimeters is the same as 1,000 milliliters. 1 cubic centimeter equals 1 milliliter. 1 cubic meter equals 1,000 liters. 1 liter equals 1,000 milliliters. And then lastly, 1 kiloliter equals 1,000 liters. So these 5 conversions that has to do with volume and capacity, extremely important. Learn them, know them, because they are not given in an exam or test. All right, so now we move on. Volume and capacity, and we are looking at measuring instruments. So I trust most of you have worked in the kitchen before, baking or cooking meals. So you would have had the opportunity to measure something with a teaspoon, tablespoon, cup, or with a measuring jug. So these are just some of the basic instruments which we use to make measurements regarding volume. Now, 1 teaspoon equals 5 milliliters, 1 tablespoon equals 15 milliliters, 1 cup equals 250 milliliters, which means half a cup is half of 250. That gives you 125 milliliters. And then we have a measuring jug, which generally has a capacity of 1 liter. Now, once again, this information is not always given. So what I mean by that is that almost 99% of the time they will give you these conversions, which is great. But sometimes you might come across a question where they refer to a cup and they expect you to already know what the volume of 1 cup is. So I would like to place emphasis on this conversion over here. out of all 5 of these conversions, this one is the one that I would expect you to know off by heart. The rest of you can familiarize yourself with them, but it is most likely that they will give you these conversions in a test or exam. Now, I would also like to just quickly stand still at this point to discuss the difference between capacity and volume. Because once again, we talk about capacity and volume, but I think many of you don't necessarily know what the difference is between capacity and volume. So if we talk about capacity, we refer to the maximum amount of liquid able to fit in a container. When we talk about volume, we refer to the amount of liquid that is in a container at a specific time. Now let's use a practical example like this milk bottle. When you purchase milk at the shop, the capacity and the volume, they are both 2 liters. Now what I mean by capacity is that bottle has the ability to carry 2 liters of milk or to hold 2 liters of milk. But after a few days of using the milk, this bottle might be half empty already. Therefore, the volume is going to be 1 liter and the capacity will still be 2 liters because the ability to hold 2 liters does not change whether you use some of the milk or not. The capacity remains the same. So I hope that clarifies it up a little bit for you, for those of you who did not know what the difference was between the two. Now, this is our last diagram. So have a look here. Kiloliters is our largest measuring unit for volume. Then we have liters in the middle, and then our smallest measuring unit is milliliters. Now, this is quite a simpler diagram compared to the previous two, but once again, it does look different. So you need to concentrate and focus at learning each diagram as its own because they do differ from each other. Now let's look at the first example. 2,86 liters converted to milliliters. Okay, so liters converted to milliliters. We will make use of the top arrow over here, which says that we need to multiply by 1,000. So if you type it into your calculator, or you can use the jumping method, this value does have a comma in. So we are going to be making 3 jumps to the right, starting at the comma. 1, 2, 3. We fill this empty jump with a 0, and that gives us an answer of 2,860 milliliters. Now, the second example, we are converting from kiloliters over here to milliliters. Now, pay attention with an example like this. You will see that we are completely skipping liters in the middle. So the calculations that we will be making use of stays exactly the same. We are now going to be making 3 zeros plus 3 zeros gives us 6. Therefore, 6 jumps to the right. Okay, and the value does not have a comma, so we start off here at the back, making 6 jumps. Okay, 6 jumps. If we fill all those empty jumps with 0, this will be our answer. Okay, so I hope all of you are understanding that these diagrams, they all work exactly the same. It's really a very easy way to do calculations. Now, this is your last opportunity to try and practice to get your answer right. So please convert 2,4 milliliters to a value in liters. Once again, show me what your answers are in the question box. Okay, I'm so happy. It looks like the most of you are getting this one right. There's a few more that is struggling with this one, but overall it looks really good. I see someone here said they gave me their answer here as a, what's the word now? As a multiplication equation, which is not entirely correct. Okay, I'm going to give a few more seconds. Okay, let's have a look. So 2,4 milliliters converted to liters, we are going to say milliliters converted to liters. We are therefore making use of the bottom arrow, which says that we need to divide by 1,000. So for those of you who made use of the jumping method, that means 3 jumps to the left. And there is a comma in this value, so we are starting at that comma, making 1, 2, 3 jumps, and our new comma is placed here in the front. This gives us an answer of 0,0024 liters. So well done again to all of you who managed to get that answer. It is great. Just pay attention. All the empty jumps that we made here to the front, we placed a 0 over there or in those jumps as a placeholder. And remember what I said, in front of the comma we always need to put a value, so we put a 0 simply to act as a placeholder. Now for today we are done with these conversion diagrams and tables. So at this point I trust and hope that the most of you at least feel a little bit more comfortable using these diagrams and that you understand how to interpret and make use of them. We are now going to be looking at 2 examples. Now, the purpose of these examples, you might find that the questions are extremely easy or simple to understand. Now, the purpose that for me doing these examples is to give you an idea of what to expect in exam papers in terms of how questions are going to be asked regarding measurement. So you will see that this question comes exactly out of a June examination 2018 paper 1. Now, let's quickly read through the question before we continue. Michelle makes porridge for herself and her brother before school. She needs water, maize meal, salt, and margarine. The table below shows the conversions for some of the ingredients. So let's quickly look at how we interpret this table. You will see the ingredients are listed here, and then the volume it is given over here. Now, the conversion that they made was between volume and mass. So you will see that 5 milliliters weighs, or 5 milliliters of flour weighs 3 grams. 15 milliliters of flour weighs 8 grams. 100 milliliters of flour weighs 60 grams. So I hope you all understand that table. And then remember, as I said, look here on the right, they give you the conversion of a cup, tablespoon, and teaspoon. So extremely important that you pay attention. They give this to you, but it might not always be there. So let's move on to our first question. The porridge needs to boil slowly for 1/3 of an hour. Write this time in minutes. Now, time is also a type of measurement, and I did not spend any time on time this morning because it is such a simple and easy concept. If you know what the number of seconds are in a minute, if you know how many minutes there are in an hour, if you know how many months are in a year, days in a week, weeks in a month, then you are halfway there. Oh, sorry. So for this question, it asks you to find out how many minutes is equivalent to 1/3 of an hour. Now, it's extremely easy. You need to give an answer in minutes. So first, let's get our units the same. 1 hour equals to 60 minutes. Therefore, we are going to say 1/3 multiplied by 60, which is the same as 1 hour. If you type that equation into your calculator, you will get an answer of 20 minutes. It's extremely easy. Question 4.2. How many grams does 125 milliliters of sugar weigh? So let's have a look here. Here we find our sugar at the bottom on our conversion table, but you see that they did not make a measurement here at the top for 125 milliliters. They did, however, give us 250. Now, we all know that half of 250 is 125. Therefore, our calculation is going to look something like this. we are going to write the ratio of 250 milliliters to 200 grams because 250 milliliters weighs 200 grams. So we're going to write it like this. Right below that, we are going to write down the information that was provided to us in the question statement, which says that we want to find out what the weight is for 125 milliliters. Therefore, right below our 250 milliliters, we are going to put 125 milliliters. The units, they are the same, therefore we place them above and below each other. Now, X represents our unknown. X is what we would like to calculate because that is the weight of 125 milliliters of sugar. So to get from 250 milliliters to 125, we divide by 2. But what we do on the one side, we have to do on the other side as well. Therefore, 200 grams divided by 2 gives us an answer of 100 grams. I hope all of you found this question easy as well. It's just a little bit of thinking, but the maths behind it is not difficult. We are moving on to the next question, so you will find that the question statement remains the same. We are looking at question 4.3. Michelle stirs 2 tablespoons of margarine into the mixture. How many grams of margarine is it? Okay, so first of all, 1 tablespoon equals to 15 milliliters. Therefore, 2 tablespoons will be 30 milliliters. Now, in the same note, you need to look here on your table. You will find that 15 milliliters and margarine, it is given here. So 15 milliliters weighs 12.5 grams. Now, if we use the same calculation, we are going to say 12.5 grams multiplied by 2, which gives us an answer of 25 grams. And that is also your final answer. Our next question. Michelle boiled 5 cups of water. How many liters of water is it? First of all, 1 cup equals to 250 milliliters. So if we multiply 250 by 5, it's going to give us 1,250 milliliters. But now pay attention because this is where some of you lose marks. You answered the first half of the question, but you did not give your answer in liters as the question states. So your final answer would be to make a conversion from milliliters to liters, and that is where this diagram plays an important role. If you say 1,250 milliliters divided by 1,000, you will get an answer of 1,25 liters. Now we are continuing the question statement and the information in the tables. Everything remains the same. Question 4.5. Michelle bought a 2.5 kilogram bag of maize meal to use for the porridge. Convert 2.5 kilograms to grams. I'm not going to take too much time on this question. Once again, this question would count anything between 2 to 3 marks. So it is 2 to 3 mahala marks, which you can easily get towards your grand total of your question or from your paper, if you know this diagram. So it's extremely important that you know this. Now we're moving from kilograms to grams, which means multiply by 1,000. And if we do that calculation, we get an answer of 2,500 grams. Our last question for this example, Michelle bought a 2.5 kilogram bag of maize meal to use for the porridge. How many times can she make porridge with a full bag of maize meal if she uses 312.5 grams to make 1 pot of porridge? Now, very important, before you even start to think of calculations, can you see that the units are not the same? So our first step, it is extremely important, will be to convert this 2.5 kilograms to grams. Luckily, we already did so in the previous question, but once again, you need to know that you need to work with 2,500 and not 2.5. So now that we have 2,500 grams, we are going to take the total amount of maize meal and we are going to divide that by 312.5. which is the amount of maize meal that she uses per pot. That means that she will be able to make porridge 8 times using a 2,5 kilogram bag. Now, that is all for that example. We have 2 questions remaining, one about temperature conversions as well. So please just stick with me for another few minutes. We are nearly done. This question is exactly copied from a November examination 2017 paper 1. The question reads, Mr. Mashaba decides to make pumpkin soup one cold winter's afternoon for dinner. The recipe is as follows. So over here you can see the recipe or the ingredients of the recipe is given, as well as the method to cook at 150 degrees Celsius. And then once again, as I told you previously in this webinar, this information is given. Now our first question reads as follows. Convert 3,5 pounds of lamb chops and 3 pounds of pumpkin to kilogram. Now this is really important. We in South Africa do not measure using pounds. We measure using kilograms. So if Mrs. Mashaba wants to make this recipe or use this recipe, she needs to know 3,5 pounds equivalent to kilograms so that she knows how much lamb chops and how much pumpkin to purchase. Now, in your conversions table on the right, you will see that they do give you a conversion here of 2,2 pounds equals 0,91 kilogram. So this piece of information here, you are not required to learn or study or know it beforehand. It will always be given to you in a test or in an exam. Now let's continue. Have a look at my calculations here. Now, these calculations were done on the 3,5 pounds of lamb chops. First, we write down the rate between the pound and the kilogram. So 2,2 pounds is the same as 0,91 kilograms. Now, the information given in our question statement is 3,5 pounds. Therefore, on the left, underneath 2,2 pounds, we write down 3,5. On the right side of this rate, we are going to put in a x. X just represents the information that we do not have. So now we are going to cross multiply for our next step. 2,2 times x gives you 2,2x. 0,91 multiplied by 3,5 gives you a final answer of 3,19. Now, the whole aim of this question is to get x alone in this equation, because x represents the amount of kilograms. So we would like to get x alone. Therefore, we are going to get rid of this 2,2, which is now kind of tied to the x. We do this by making use of opposite calculations. So this side, 2,2, is being multiplied with x. Opposite of multiplication is division. Therefore, to get rid of this 2,2 on this side, we are going to divide with 2,2 on the left of the equation. Therefore, 3,19 divided by 2,2 gives you an answer of 1,45. Okay, now let's continue. This calculation is now done to convert 3 pounds of pumpkin to kilograms, and it works exactly the same. So once again, the rate is given 2,2 pound, the same as 0,91 kilograms. They give us 3 pounds of pumpkin. The 3 we write down exactly underneath 2,2, and x once again represents the information we do not have. We cross multiply, which says 2,2 times x gives us 2,2x, then 0,91 times 3, which gives us an answer of 2,73. And then once again, to get this x all alone by itself, we are going to take this 2,2, and instead of multiplying it, we are dividing it with 2,73, which gives us an answer of 1,24. So your final answer will be 1,45 kilogram of lamb chops and 1,24 kilograms of pumpkin will be required for this recipe. Our last question, convert 150 degrees Celsius to Fahrenheit. Now, extremely important that you note the conversion formula for temperature is given. So please do not go and study this. You will also sometimes find that this formula might look a little bit different to the formula that is given in your textbooks. They are all actually the same. So 9/5 might just be given as a decimal value instead of a fraction. So they all boil down to the same formula. But the formula, once again, always given to you. So your first step to answer this question will be to just simply copy your formula to where you are going to do your calculations. Then you are going to substitute your information into the formula. So we want to determine the degree Fahrenheit, but we have the degree Celsius. So what we are going to be doing is simply taking this 150 and substituting it into our formula. Next part is fairly easy. You type this entire equation into your calculator and it will give you an answer of 302. And that is about as difficult as a temperature conversion question can get for grade 10. So that is all for today's discussion. Then I please just remind you to download the handouts. There is an additional revision task included just for some extra practice during this time that we are at home. And then you must also remember to please submit your questions if you have any in the question box so that I can get back to you after this session. Thank you so much for joining me today.